Okay. So today we'll, as I told you before, we have done a little, we have done the derivation of these Simpson's rules and trapezoidal rule. Simpson's rule. We'll just extend that a little bit and see some examples. So I have already defined to you that you can have your trapezoidal rule or a Simpson's rule. Now some things that we probably I didn't stress on last time was when I was taking that was first of all you know that the Simpson's rule will say that the area is given by 1 by 3 h into y0 plus y1 plus y2, okay, something like y0 plus 4 y1 plus y2, or it will become 1 by 3 h if there are more terms, 4 y1 plus 2 y2 plus 4 y3 plus y4. Okay. So you will get a Simpson's rule like this. Now you will notice one thing here is that is in the if you want to have this area, if you want to use this method, in this case you are having 3 ordinates, right, means y0, y1 and y2. In this case you are having 1, 2, 3, 4, 5. The thing is you cannot do this method if you are having an even number of ordinates. It can be 3, 5, 7 like that, because you cannot have a multiplier like 1, 4, 2, 1. It cannot end like that. It always ends as 1, 4 and 4, 1. Okay, that it should always end like that. So there and something in between will be there. So it will always be an odd number. Yes, it should always be an odd number. So what do you do if you have an even number of ordinates? Of course, the simplest way which I suggest you do is use the trapezoidal rule. Trapezoidal rule has no such limitations, that is you can apply it to any number of, it's just 1, 2, 2, 2 to 1. So it can be any number of 2's there, that is not a problem. But in real practice the this formula is actually known as Simpson's first rule. For completeness sake I will just do the whole thing, that is this is known as the Simpson's first rule. This 1, 4, 2, 4, 1 is known as the Simpson's first rule. There is also something known as a Simpson's second rule, which deals with, it starts with 4 ordinates, that means an even number of ordinates. So I will derive this. Before that there is something which I left last time which is very important. I told you that suppose you are having half ordinates, we already said that if it is like 0, half, 1, 1 and a half, 2, something like that, how will you solve that problem? So let us just do one problem like that, and when you, because you, and remember you won't have, you might not have this same problem, means 0, I might give you 0, 1 by 4, 1 by 2 like that. It is just an extension of this, you know the method how to do it, that is it. So let us take this problem. You have a y0, you have y1, y2, some y3 and y4, and here you have y half, and here you have y 3 and a half. So let me just say this is y0 just to make the smooth curve. So this is, okay, it's something like this. This is the curve, and you are now asked to find the area of this section. Now of course we will use 1, 2, 3, 4, 5, 6, 7. We can use the Simpson's first rule because it is 7. Now we have here, this is the problem that we are having. 1 minute, sorry. That is your so you are having a y half, you are having a half station, and you are having a 3 and a half station. Okay. So this so the simplest method is, what you do is you first take these 3 points and you find the area of that, that is area of 1, you take these 3 points and you find the area of this, area of 2, and you take these 3 points and you find the area of this, area 3. Okay. So, we are now split the whole problem into 3 sections, and since our goal is to find the area, we will just add these 3 areas. So, the first area, area 1 is given by h by 3 into y 0 plus 4 y 1 plus y 2, the basic Simpson's rule, which we can write as no, in the thing is here. Okay. Now, let us call this separation h. Okay. This is your real h, means it is the distance between 2 stations, that is 0 and 1, or between 1 and 2, 2 and 3, that is the separation, that is h. So, obviously, the distance between 0 and half becomes h by 2. Okay. So, this is h by 2, therefore, this becomes h by 2 by, right. It is actually h by 2 by 3 of y 0 plus y 1 4 y 1 that is the area of this section. Okay. And therefore, it becomes, we can write it as h by 3 into y 0 by 2 plus 2 y 1 plus y 2 by 2. Okay, it is all right, plus y 2 by 2. Then area of the second section is area of this is given by h by 3 into y 2 plus 4 y 3 plus y 4, that is very obvious. Y half, sorry, plus y 1, correct. Okay, I made a mistake there. Correct. H by 3 into y 0 by 2 plus y half 2 y half plus y 1 by 2, right, correct. Now, area of the section 2 will be h by 3 into y 1 plus okay, here they have made a mistake, h 1 y 1 plus, we will do it ourselves, we y 1 plus 4 y 2 plus y 3. Then area of the third section is h by 2 by 3 into y 3 plus 4 y 3 and a half plus 1 y 4. Okay. All right. Now, so what you want to have is the total area, which is area 1 plus area 2 plus area 3, sum them up. Actually, if I cannot write the values here because this is wrong. So, we have to actually sum it up. So, you will get a value, it becomes something like y 4, okay, all right, it becomes this, I will do it h by 3 into y 0 by 2 plus 2 y half plus 3 by 2 y 1 plus 4 y 2 plus 3 by 2 y 3 plus 2 y 3 and a half plus y 4, okay, y 4 by 2. It will become like this. I mean, so you cannot really predict your answer in this case, it is not very of course, you can memorize this, that is a different thing, you can do that, and but you won't have the fixed number of the same number of ordinates. So, you do not memorize any of this, that is not the goal. Your idea is to do this, just to do this summation. Okay. So, the only thing to remember is this is h by 2 and this is h, that is the only thing to remember, and other than that, if you have all your y zeros and all proper, you just sum up the, divide it in such a way, because remember you are doing Simpson's first rule. So, 3, you take 3 ordinates, always take 3 ordinates and divide it. then you won't make any mistake. Of course, you can divide it into 5 and 3 like that, but to be better, to get a better answer, it might be better to divide it in groups of 3. That is the only thing to remember when you are doing the Simpson's rule. So, put it in groups of 3, you make it into areas, sum of the areas. Okay. So, this is how you, so now you know how to do it for if you have a 1 by 4 ordinate also, same thing. So, that derivation of that multipliers is, it's a very important thing. So, that is how you have to do for different multipliers, for different kinds of stations. If you have to do this thing. Okay, then, so as I told you, there is something known as Simpson's second rule, that also we will just mention, but if you want, you can do one thing. If you are having an even number of ordinates, you apply trapezoidal rule straight away. It's not wrong, it's okay, but this is just for you have to know this Simpson's second rule. Since this is not that important, I won't do the derivation. I will just tell you the method. What they are doing is, in this case, you are actually replacing this this curve y is equal to f of x by a third order polynomial. Okay. The other time we used a parabola, a second order polynomial, quadratic equation. In this case, it becomes something like a third order bx square plus cx plus d. Okay. And the derivation is a little long, so we will skip that, and we will just write that. Just know this value, this way of writing, it's equal to 3 by 8 h into y 0 plus 3 y 1 plus 3 y 2 plus y 3. Okay. So, this will give you the total area of the total area that you need to do. Now, suppose you have, so of course, what you have this problem, for instance, has 1 2 3 4 5 6 7 for instance, if you have a problem like this, just to mention, that's all, means suppose you have y 0, it's y 0, y 1, y 2, y 3, y 4, y 5, y 6, means you are having a system like this. You can find the if suppose you are asked to find, there is a curve and you are asked to find the area of this curve. So, what you do is you can divide it into one region here, 4 ordinates here, 4 ordinates here. See this, these 4 as 1, these 4 as 1. You find the area of this section, and you sum them up. That will give you the total area of this whole section. So, this is one method of doing using. In fact, for all cases, you can just apply trapezoidal rule and make it simple, and there is nothing wrong with that. You can do that. Just this, but this is what is really followed, Simpson's rule, because if you remember, we saw that the error actually is much lesser if you use Simpson's rule, and obviously you get better accuracy. So, we follow that in real practice. Now, this problems, these kind 2 or 3 problems I will do, which will tell you how to not only just do the Simpson's multiplier, but that will also give you an idea of what exactly, given a table, you will see some tables. We have already drawn some tables already. When you see those tables, what exactly can you get from the table, what values can you get. For instance, suppose you are given that so here you are having a table like this. Now, you know what this means, right? If you are given a table like this as stations and half ordinates, okay, the meaning of it is, I have already explained to you, this is the stations and these are the half ordinates at each point. So, you are given at different stations what are the half ordinates. Now, you are asked what is the area, find the area of the water plane. So, these half ordinates are obviously at the water plane. So, you have a ship, you have a water line somewhere, you are asked to find the water plane area, you are given y's at different points. Now, when you sum up the y's, y dx will give you the area of this, that is the area of the water plane. Okay. That so, there is no need to do what you, the way to solve it is, means you make this table, this is the standard format of the table of any problem like this. Station, half ordinate, I will write Sm for Simpson's multiplier, and this is the function of area. Okay. All right. Okay. So, this is the way in which you do make the table. So, you have a table like this with stations, you give the ordinates here, half ordinates are given here like this. Now, you can see, look at the number of, you can, in this case there is 1 2 3 4 5 6 7 number of coordinates. So, you can apply the Simpson's first rule. Okay, it is 7, it is odd number. So, you can do this. So, for this problem this is possible, it comes like this 1 2 3 4 5 6 7. Okay. So, this is okay, and then you find the function of area here. What is this function of area? It is this half ordinate into this thing, Simpson's multiplier. Okay. So, you have that, then you sum up the half areas, sigma, I mean sum up the total function of area, sigma function of area, and you apply this formula h by 3 into that. H will be the distance between the stations, that is given, that is given. Yes, you are told that vessel is 90 meters and it is divided into 1 2 3 4 5 6 equal stations, I mean 7 stations, that means 6 equal regions. So, 6 equal parts. So, 90 by 6 you do that. So, h by 3 into this summation. Okay, this will give you the total area of the water plane. So, this is this tells you not just that how to find the Simpson's rule, but that also tells you from the half ordinates you find the water plane area, that is the first thing. Actually, there are couple of things like this. This is one, from the half ordinate this you can find the water plane area. Then similarly from the y's means okay, let me draw this here. So, you can be given, this is the ship, assume this is the length of the ship, the longitudinal, this is the longitudinal direction of the ship. Now, if you are given the y's, half y's is enough, let us call this y1 like this, the ship is like this. Okay. Let us say it is like this itself. Now, if you are given in this particular problem, you are given this y1, y2, y3 like that, and you are finding this water plane area. Similarly, then another problem can be, you are given a section, by now you definitely know what is a section, this also let us take just the half. Okay, you know the section and you are finding the area, you can be given these lengths. What does it mean? It means the half ordinate at each draft. So, this is the half ordinate at various drafts. Okay. So, you are told that at a, this is a draft, at a draft of 0.25 meter, this is the half ordinate. So, what do you get? You are actually getting what area? Sectional area. So, you are getting a sectional area, and what will be your h here? Distance between the water lines. These are water lines, right? Okay. So, your h will be the this distance, this will be your h. So, it will just be your distance between the water lines. So, this is one area you can get, this is another area you can get, and third one, actually there is no point doing the problem, I will just, that is you, another possibility is you are given The okay, this is the same thing, half ordinate is given and you have to find the area, that is not important, we have done that. Okay. Yeah, another thing is you could be given at different drafts, means this is the ship, this is the ship, and at different drafts, that means at different cross sections or different water planes, you are given what is the water plane area. These are different drafts, let us say draft of 0.25, draft of 0.5, draft of 0.75, like that. You are given at different drafts what is your water plane area. AW, this is always written as AW, AW means water plane area. So, water plane area at different drafts are given. So, what can you get from Simpson's multiplier? Volume, you can get the displacement. So, again your h becomes the distance between the water lines, which is the different drafts given. So, this is the third possibility, this is the third type of region. So, these three I think are the main areas calculated using this Simpson's multiplier. The next one possibility is to calculate I, moment of inertia. We have already done a problem similar to that. So, that I think you kind of know that now. All right. So, I think this is enough for the integration. Now, we will continue with okay. We will now go into couple of problems. No, first we will do this, that is we are talking about the heel, okay, which is also called as list. Okay, we are going into this problem. Now, first let us look at some aspects dealing with the center of gravity for the time being, not with the center of buoyancy, but with the center of gravity. We will see that. That is, for instance, suppose you have a section like this, now we have a section of a ship, this is your water line. Now, the problem in this case is you are given that, let us say that the total weight of the ship is capital W, and let us suppose that there is a small weight on the ship, small w, that is displaced from this point initially, from here it is displaced to this point, okay. W is shifted to this point. Now, let us, as you know, the first of all the center of gravity will shift, because center of gravity, the body itself shifting, a weight is shifted. So, the center of gravity of the whole ship will also shift a little bit, because it is only a small weight, it shifted, it moves to a new point initially without shifting it is at g0, and because after the shifting it is at g1, because the body has shifted in this direction, g also will shift in that direction. This is the g of the whole ship, okay, not g of. Then now, for this case let us derive some relations, that is, let me now what will happen if there is a shift of weight, body will, I mean the whole ship will actually incline, okay, heel, that is listing. Then let us say that it is the body has heel like this, W1 L1. So, because of that, that is the g has shifted here, the center of buoyancy has shifted here, B2 B1, actually B1 and B2 will be in a straight line, okay. So, or more or less it's it's just the drawing. So, G will shift to G1, then now what will be, let us call this angle as theta, tan theta will be G0 G1 divided by G0 M. Now, what will be the shift in the center of gravity of the whole ship because of the shift of a small w through a distance, let us call this distance d. This we have already derived. I mean, if you have a system of m1 plus m2 and if we shift just m1, how much will the center of gravity of the whole system shift? That is, we have seen that it is given by it will be in this case w into d by w. Okay. Therefore, G0 G1 G0 G1 will be given by w into d by w. This is small w, this is capital W. Okay. Then actually this is useful. Okay. Therefore, tan theta equals G0 G1, which is w into d by w divided by G0 M. Okay. Now, this is a formula. Okay. This is a useful formula. This gives, actually remember, there is a small change, that is this theta actually represents the heel only. Okay. This is how, this is the angle through which the body has heeled. I said actually in the beginning that we for heel we will use only phi, and for this book has used theta. So, note that this is just actually your phi. We have talked now till phi, because till now I have said that everything will be dealt with as phi. So, we can use phi, no problem. The concept is that tan phi will be given by so from this you can get the angle of heel, because if a body is shifted from one point to another on the ship, because of, if you know the distance through which it is shifted and the weight of that body, you can find the angle through which the body will the whole ship will heel because of this shift. So, w into d, that is given by this. The only thing you need to know is gm, okay, gm of the ship. Okay. Now, we can do one problem that gives you an idea of this. Now, actually I will read out the problem so that you understand how this. That is the vessel displacing 11,000 tons. So, the meaning of that of course is that the displacement of the vessel is 11,000 tons, 11,000 tons, and it has a kg of 8.7 meter, it is given. It has a km equal to 9.5 meter, and it is said that it has an initial list of, or an initial heel of 2 degrees to the port side, initial heel of 2 degrees to the port. Okay. So, port is this side, it is heel like this when you are looking. Okay. Then you are told that the ship loads, ship is, now what we are going to do is we are going to add new loads to the ship. So, the ship loads like this. Okay. Now, you are given a couple of details, means what do each of these mean? First of all, you are told that the ship is loading first 400 tons, it is loaded at a kg of 10, that means the kg of that load is given to be at 10, okay, 10 meters. Then distance from the center line, what does it mean? Means this distance, this distance, this distance. Okay. So, the distance from this is the center line always. So, when you have a ship like this is the center line. Okay, this is the center line of the ship, and this distance is the distance from the center line. Kg is this distance. So, you are given this distance and this distance. Now, why do we need this distance? It is actually to find this g0 g1. It is a horizontal distance through which g has shifted. Of course, your problem is we have to find the vertical distance through which g has shifted, 1. Then you also need to find the horizontal distance through which g has shifted to get g0 g1, and if you know g0 g1, then you can get tan phi, and you will know how much it has healed. That that is a problem. You are asked initially it has this heal, but after you load this, what will be the new heal? So, this is your question. Okay.
So, what is that unit?
Which one?
Distance from center line.
Yes, this is port and this is starboard. That is another, we will do this. Then now first you are told, okay, the initial case, that is before you are loading these new weights, tan phi can be given as g0 g1 divided by g0 m. Now, how will you find g0 m? Remember, g0 0 always means before the experiment or before whatever you are doing, before the. So, this initially this represents your initial case, but note that this is not an upright case. In the initial case itself, the ship is in a heeled condition. Then you are adding loads, it becomes even more heeled. That you are asked what is the new heel. So, this is tan phi. Now, how will you find g0 m? G0 m is straightforward. You use this your km minus kg, kg0 we can say. So, this will give you your g0 m. So, these two are given. So, initially the ship's kg is given, that is your kg0, this thing, and that and km is also given. So, here this is the problem. So, you are given kg, this is your kg0, and from this you are given km. So, from these two you can get g0 m is this minus this, km minus g0 m, kg0. So, from this you will get something 0.8 meters. So, this gives you your g0 m. Now, we come to this problem, tan phi is equal to g0 g1 by g0 m, that is our, right now we have derived this. Now, we know g0 m, we know tan phi, this is initially in the before the loads have been added. So, this is when your it is already given that it is a list of 2 degrees in the port side. So, tan of 2 degrees is equal to g0 g1 by g0 m, okay, and this comes to implies, this will imply that g0 g1 is equal to some 0.025 or something meter port. That means, the value of g initially is at a distance of so much meter to the port side, it is not on the. So, actually it is heeled like this, not like this, it is heeled like this, it's the g is somewhere here, g is little distance away from the center line, it is there. Okay. This is your initial condition. Now, we have solved that. Now, your problem is we have added loads to it and you are asked to find out what are the new values of heel. Now, so in a way this whole more or less the whole of this course, all the problems that you are going to do are going to be with making such tables only, okay. Different kinds of data, but you always end up making such tables and some kind of summation of areas or volumes, in this case moments. Okay, now I have made a whole table like this. You have weight, you have kg moment. Now, g from center line means the distance of g from center line of that particular load, then the moment of this due to this weight and because of this distance between the center line and g, there will be a moment acting, that moment is given by this. If it is on the port side, I will write here, if it is on the starboard side, I will write here, because remember, if this is the center line, if this is the ship and this is the center line, you will, and this is the one is port and one is starboard, g is anyway acting down. So, it is acting, if one, I mean the moment acting on the port side will cause it to tilt like this, moment acting to the starboard side will cause it to tilt like this, to heel like this. So, it is opposite in sign. So, that change in sign, to take care of that, we are putting it as two columns here, moment in port and moment in starboard. Finally, you just subtract them, you will get the final value. We will see that. That is okay. First, you are told that you have the, we have the ship alone, that is 11,000, and your kg is given to be at 8.7, it is given, and therefore, you find the moment, there is no need to do it, you do the moment. Now, right now we have calculated the position of this g from the center line, this distance. Okay. So, this you write here 0.025 to the port side. Okay. I will write it p. Therefore, because it is to the port side, this moment is to the port side. What is this moment? This moment is actually the moment causing it to incline in this into the port side, port direction. In this, it is given by the weight into this distance. Okay. So, this, that will give you the moment here. Now, you add the different weights. For instance, I will just write the first one 400, then you are given its kg is like here, you are given 410 and 4.5 port, that we will write here 400, this becomes 10, and you get the moment, this is the product of these two, and 4.5 port. So, again you will have a moment to the port. I mean like this, all these weights you have to do. Okay, you have to write, this one is on the starboard side. So, this will actually come here. Okay, the third one, this is 6 meter to the starboard side. So, this will come here in the starboard part of the moment. No, I am saying this one, and these two are ports. Okay. So, these two will this will come here. So, eventually you have such 4 such 1, 2, 3 and 1 for the whole ship. So, this is there. Now, how do you find the total? What exactly do we need to find? First, we need to find that is, first let us find kg 0. It is not kg 0, it is kg actually. It is not kg 0. Kg 0 means initially before the loads are added. Now, once you add the load, it becomes kg. Now, you are asked to find what is different loads are added at different points. Now, what is the new position of your kg? So, kg will be your, you have here, okay, you have the moments here. Okay. These moments divided by the total weight. Is it clear, or is it, or are you getting confused? Yeah.
These moments are taken about which axis?
Which about the center line.
Sir, the initial position we have been given that.
Wait. This moment is taken about the, there are two moments here we have taken. This moment is taken about the center line, this moment, and this moment is taken about the keel. Okay.
So, the weight of the whole ship, for that which axis is used for 11,000?
Which one? Both of them are using 11,000. This will be 11,000 into this will give you this moment. Means you have the center line here. I am saying that this 11,000 tons is so many distance heeled away from the, it displays so much distance away from the center line. So, so that weight into this distance will cause it to heel like that. That is the moment. So, it is about this axis.
The original
center line. Yeah, and then okay, now okay, all right. Other than that, look, I mean lot of look confused, a lot of people.
Sir,
is it
kg is parallel to the weight direction of weight, no?
well, actually it's yeah, I am calling it moment, but it's not really moment. What we are doing is we are finding the net kg. For that, moment means it is like means there is one weight here, there is one weight here, there is one weight here. Now because of this, what will be the net centroid of this whole weight? So this product is what I am calling as moment. That's all. It's not a moment in the as a vector you are thinking of it. It's not, that's not what we are doing here. It is when in the inclining case, yes, it is a moment really. What I am saying is, I will tell you, that is when we are always finding a centroid, we always do m1 d1 plus m2 d2 like this, right. So this thing I am calling as a moment, that's all, okay. That and okay, now there is a good question then. So this is how you get the total weight, okay. This total weight is after all the loads have been added, and you have the total moment here. This moment is to find the kg. That means you have weights at different points, you are just finding where the net acts, okay. So that is kg at different points. So this will give, this is just to find that kg, and this is actually what you are thinking of. It's actually we are talking about real moments. It's a vector in that sense. One moment is causing it to heal like this, one moment is causing it to heal like this. We are finding the summation of that, and that much moment is the net healing or healing to the starboard or to the port side. That is the net. That's what actually you will see. For instance, suppose you added these four quantities and you ended up with some value. Suppose you ended up with a plus sign, that is very important. We have put this as positive and we have put this as negative, okay. So if you get this as a plus sign, that means it has healed to the port side. On the other hand, if you get it as negative, it means it has healed to the starboard side, that's all, okay. Now here we have to find the kg. So kg will be just this total moment divided by this total weight. So that is done there, that is quite easy. Then km is given again. Km doesn't change because it is just a tilting of weights and km hasn't changed, and it's just it's the same thing. And you then do gm, new gm, which is equal to km minus kg. This will give you a new value of gm. Then now you have to find what is your g1, okay. Means what is your net horizontal movement of g. How will you get that? You have the net horizontal moment, you have the total weight. When you divide the net horizontal movement divided by the total weight, will give you the net horizontal movement of the g. So g1 moment about the center line, note that this is again about the center line, and divided by the displacement. So that you just do that and you will get, then we finally apply the formula tan phi is equal to g1 divided by gm. Note that we have calculated gm here, we have calculated g1 using this formula. So to do that, we need both this moment you have to do to calculate gm, you need this to calculate g1, and once you have this, you can get tan phi. Very simple formula, you can just apply this, okay. So this is the this is how you find out the new heel due to a weight being shifted, okay. Now there is a slightly similar problem, slightly different, that is now this problem is that initially there is a weight, okay, the whole system same thing, there is a capital W and let us call this a small weight sitting here at small w. Now the problem is what you are doing is first you are going to hang the weight here, means it's going to be suspended, it becomes like a simple pendulum. Okay, this weight is suspended here. Now this is a very important experiment, because that's we will do that in the probably in the next class, something known as an inclining experiment. It is used to find the kg of the ship. So the beginning is like this, that is first, okay, in this problem what we are doing is we have this weight and we are suspending the weight somewhere here, it does not matter, and let us say that at a height d from or this height is called d1, this is a height of d1 from the base, the keel of the ship. Okay, so here it is suspended somewhere. Okay, then now suppose that the ship heels due to some mechanism, the ship heels. Now because of this, what will happen, this pendulum will remain straight, that means the ship has heeled, the pendulum will actually remain straight, it will be like this. This is your new W1 L1. So pendulum will actually, this will actually be in the new figure, it will look like this. Okay, like this, it is hanging, so it will be like this, right. Note that this will be perpendicular to this, because pendulum will always be hanging straight, it will look like this. Now horizontally, actually this is in the ship only. Okay, it is not as if the suspension point is outside the ship, it is on the ship only, something on the ship, let us say a lift on the ship maybe. Okay, it is because the weight is not going outside the ship, weight is still on the ship, so W is still there. Then let us suppose that now we can see that in this figure itself, this has displaced through a distance d0 horizontally, through a distance d0. Now our problem is to find out some relation between all these three. We will, that is first, now initially this weight is remaining here at W and in the keel. Let us say that the center of gravity is here, g0. Now the moment you hang it, you will see that it acts as if the weight is here, it is no longer going to be as if the weight is here, is that right? You can think logically, no, because the weight is hanging there, the force is acting here, therefore the g of this weight is actually shifted there, which will imply that the g of the whole ship will actually go up a little bit. So this g0 will go up here to maybe g1, and then what happens, the ship has heeled. So first the weight is, so this is the two steps, first the weight is suspended, first the weight is at rest on the keel, then the weight is suspended, then 3 the ship is heeled. Now the ship did not heel because of the suspension or anything, ship heeled because of some reason, because of some external force acted and ship heeled, because of which the inclined weight shifted. Okay, all right, this is the, now because of this the g0 shifts to g1 first. Now when the ship heels, inclines, this weight goes horizontally, you have seen here a distance d0 is gone horizontally, therefore this will move here somewhere, we cannot say exactly, let us say g2. Okay, now the important thing is, we are assuming that it is actually a very small heel, it is not heeled much. So this is not a very large angle, very smaller angle. So it somewhere here small, somewhere it g0, g1, somewhere there it like this. Okay, g1 it has shifted there. Then now we are using a little bit of just intuitively thinking, that is, see this figure shows that you have this weight shifted here. Now look at this g, this is, now you see that the movement of this g should be really proportional to this movement of the weight itself. Now therefore what actually it will follow from but that derivation is too complicated, what means it will can by general intuitive thinking itself, you will see that these two triangles you have here will be similar, actually not same, it will be similar. Okay, because one is actually proportional to the other. The g is actually moving directly proportional to the movement of the weight. So, because of that these two, so you will have these two triangles where the angles subtended by d0 and d1, the d1 and d0, and here you have some distance g1 g0 and g2, I mean g1 g0 and g2, this is g2 g0, okay, to that angle will be the same. So, you will have something like g1 g0 divided by g0 g2 will become, so I will just call them O, P, and this is Q. Okay, then now what we are saying is that the two triangles are similar. So, you have g0 g1 g0 by g0 g2 is equal to OP by PQ, which is equal to d1 by d0. Then I just do this g0. Okay. Now, what is the horizontal distance through which the whole center of gravity of the ship will shift if a small weight is shifted? The same formula that we have used before, that same concept. So, this g0 g2, which is the shift because of the weight shifting through this distance, what will be that shift in the center of gravity of the ship? This g0 g2, it will be, let us say that W is the weight of the small mass, so W into d0 divided by capital W of the ship. Okay. Now, so you have g0 g1 divided by W into W by d0 equals d1 by d0. It comes directly from the previous equation. Therefore, you get g0 g1 equals W into d1 by W. Now, this is actually representing your g0 g1. What is g0 g1? It is actually the shift in the center of gravity of the whole ship because of what? Because of the suspension of the mass. Means you have actually initially it was on the body, it was on the keel itself, you suspended it. The moment the body was suspended, still remember that it is suspended on the ship itself. Actually, it will be different if it is suspended outside. If it is suspended outside, it is like the weight is removed. In this case, it is as if this weight is moved from here to there. So, that because of that movement, g0 will shift from g0 to g1, slightly it will go up. That distance is given by this formula. Now, by doing such problems, we will see that we can get the center of gravity in a very nice fashion. So, this is actually there is a problem associated with this also. I do not know if there is, I will just explain quickly part of the problem. You are told that okay. Oh, this problem is similar to what we did last time. This just says that okay, this problem just says that you have a ship again, you have a way. Actually, the thing is probably what I should explain, I will do that in the next class. Couple of things, there is a statement that looks a little strange, like it says the lift is to be discharged into a lighter, at which time the derrick will be plumbed 12 meters to starboard of the center line and the head of the derrick will be 29 meter above the keel. The wording is little strange because you do not know what is a derrick, you do not know what is a lighter, keel you know. So, such things because you will get problems like this only. So, we will actually have to explain what each of these, but we will do that, we will do this problem in the next class. Okay. But this way of doing it you should know, that is this table, one table you should draw, you can always do in this same always draw the table. Please do not do write continuously like kg of 1 kg 2, please draw the table and do it, because otherwise mistakes are very common. So, always like this, weight will be there, kg will be next, moment will be next. This much is needed to get your new kg, means in any case what you are going to have, some weight will be added somewhere, some weight will be removed somewhere, and the concept is going to be the same thing. So, So, this always write like this, from this you can get the net kg, and in these problems you need one more thing, the horizontal movement of the g, for which you will have that horizontal distance of g, horizontal distance of g from the center line, and then you will have the moment. You can do two things, you can put the port moments as positive and the starboard moments as negative and just do it, or you can put different moments and do that, but maybe a concise way of doing it is port moments you put it as positive and starboard moments as negative, and in one, so in one table like this you make the whole so, and this moment divided by the total weight is, suppose this is the problem basically, and you just have to solve in just written in a different fashion, that is all. So, but make this table, okay, whenever this is a fashion, at any rate make a table, and any calculation to do with kg, kb, anything, you start with the table, that is okay. Thank you.